Hello, everybody. Thank you for being here today. The talk is going to be about real-time facial animation using Mixamo, Face Plus, and Mecanim. My name is Stefano Corazzo. I'm the CEO and founder of Mixamo. And we also have here with us Charles Pina, who was the lead developer of Unplugged, the short that you guys have seen at the keynote. We have Emiliano Ganbaretto, who is the director of research at Mixamo. And then we have James Zachary, that was the director of Unplugged, and he also was before lead animator at LucasArts and animation director at Activision on Spider-Man. And he joined us this year, and specifically for this project. So before we start, I would like to ask a few questions to the audience so we can tune a little bit better the talk. So how many of you have ever used facial animation in your games? And how many of you are planning to use facial animation in your game in the next 6 months? And how many of you are planning to use it in the next 6 days? And how many of you in the next 6 minutes? Yes, I like you. All right, last question, the most important. How many of you are wearing right now white socks? All right, I always do this stat, and actually it's very important. Thank you. It's 26. Thanks a lot. Okay, so at Mixamo, we have one mission, which is democratizing character animation. That's all we are about. And over the years, we try to focus on creating a complete solution that people can use, our one-stop shop. Also remembering then the best way to make decisions for a game is experiencing how the game feels like. And then the third one is knowing the game developers really need fast iterations. They need to be able to try assets in the game really fast and not wait weeks for the content to come in the game. We work also with a lot of game developers on a one-on-one basis, so doing custom animation work for games that go from AAA level to all the way to mobile. This helps us always stay in touch with our customers, understand their needs, and then in many cases we can take the same animations that we develop, for example, for Spider-Man and Jurassic Park, and put them on our website. So all the animations that you're getting for very little money are basically the fruit of thousands of dollars of large studio budget that now they basically allow us to put on our website. So we have basically built all this pipeline because we believe in the emotional power of character animation. We believe that games that have a character that can tell a story are more powerful and people will engage more. So we really love the storytelling aspect and the emotional aspect of games. And so we have built a pipeline that started with animations, and then we expanded that including all our animations inside the Unity editor through a plugin called Unlimited Plus. Then we realized that rigging was a big problem, and so we developed an auto-rigging solution that is now available on Mixamo as of last year. That is the only automatic rigging service in the world so far, as far as I know. And then yesterday, we announced our first modeling and texture tool, which is called Fuse. It was done in collaboration with Algorithmic, and is now in what we call tech preview. We're going to expand the content they will have, but basically allows people in a couple of minutes to create a character, rig it, animate, and then bring it into the engine, which is the ultimate goal. And this is all packaged into one thing that is called All Access, which is a yearly subscription that is sold either on our site or on the Unity Asset Store. So you can buy either ways. So what was the missing piece in all this was facial animation. We didn't have a solution for facial, and we wanted to be this one-stop shop. So we went back to the drawing board on May of last year, so about like a year and a half ago, and we thought, okay, where can we take it? Can we rethink the way people do facial animation? Can we take a pipeline that normally involves, putting markers on the face, a bunch of cameras, proprietary software for mocap, maybe Motion Builder or Maya or other software, and then I finally get into the engine. Can we collapse that into a real-time fun experience where I can iterate fast and I can make fast decisions for my game? So this basically converge into both a technology development project called Face Plus that was led by Emiliano, and also a showcase animated movie called Unplugged. You have seen 40 seconds of that during the keynote, so now we're going to show you the full thing running in the engine. It's about 4 minutes long. Enjoy. the entire project is available at mixamo.com/unplugged for commercial and non-commercial use. Anybody can download it and use it. All you need for now is Unity 4.3. And we would love to see what you guys are going to do with that. Make a game, surprise us. And then now I'll let James talk a little bit more about the process and all the behind the scene and the philosophy about facial animation that we embraced.
Cool. Agree. Cool. Yeah, as Stefano said, I've been in the game industry for a long time now. And I was brought on to Mixamo to direct the animated short you just saw, Unplugged. And I was brought on as a user, as a content creator. I was kind of brought on to represent all of you guys. And as a content creator and as a storyteller, we started thinking about what can we do with facial in games? How can we push it beyond just simple speech? So this is what we set off to tackle in Unplugged. And we wanted to do more than just talking, just opening a mouth. We wanted to go beyond that. And in visual storytelling, they have a saying, it says, show, don't tell. Well, that's exactly what we wanted to do. We wanted to show emotion. Check out these images. So much can be told without ever saying a word, right? Just an individual, how they hold their mouth or how they move their eyes. It says a lot about that character. So this is where we decided to go with Unplugged. We wanted to capture the face, not just speaking, but truly acting. We wanted to capture it, what was going on in their mind. We wanted to see those wheels turning in their head. What were they thinking? Were they figuring things out? And we did this so you guys can do acting in your project as well. So now there's 4 different ways to do facial animation in games. So we'll just kind of dive in and go over them. So these are basically the 4. In the past, on the projects I've been on, we used one of the 4 or a mixture of them, whether it was on Spider-Man or Star Wars 1313, a moment of silence. But anyways, we created facial animation using one of these 4 procedures. So the first one is keyframe facial animation. Second is procedurally driven facial animation. Third is traditional facial mocap. And the 4th one is desktop facial mocap. Example, Face Plus. So let's kind of dive in and get the pros and cons of each. So keyframe animation, we all know what this is, right? This is what Pixar does. And it takes a very talented group of animators to pull off. The animator gets in and handcrafts every second of the performance. And the results can be outstanding. We love this stuff. But they could also be horrendous if you don't have top-tier talent. And overall, though keyframing is what animators love to do and we love to watch it, it is very labor-intensive. And the feedback loop is quite slow because you are getting in there and handcrafting and figuring out the poses and the timing of the performance as you go along. And since it is so time-consuming, it's very hard to have organic changes towards the end of a project. Keyframing can also be quite inconsistent, too. The saying, you're only strong as your weakest link, that holds true in animation as well. So if you have a team of animators or a group of guys that are great at animation and then a couple guys that aren't so great, you got to kind of pull it in to have that consistent level across the shots or across your levels. Next is procedurally driven facial animation, right? So procedurally driven facial animation uses an audio track to drive shapes or phonemes on the face. You basically feed in some audio and the face moves to match that audio. And this process can be extremely fast and the results are often mixed. With audio-driven facial, you get the lips to move in sync, but you kind of miss out on the underlying emotions of the scene. It's just hard to get a character to act happy or sad or angry or hurt by procedurally reading an audio file. But again, it's a very fast option and is quite affordable. But just remember, you're going to need an animator to go back in and put the performance back. Next is traditional facial animation, or traditional motion capture. This is what we see in the movies, right, and all the high-end games. It uses motion capture cameras and markers and dots on the actor's face to capture their movement and to drive the blend shapes. It's definitely the best way to go if you have the money. But unfortunately, it's out of reach for many developers out there. It's what we use in Spider-Man or on Star Wars 1313, and it gave us great results, but it was extremely costly, and it was a very slow and cumbersome process. Just managing, booking actors, casting, getting the mocap stage, sending assets back and forth. dealing with the logistics of actors and animators and audio files, and then capturing the data, processing the data, cleaning the data. I mean, it quickly snowballs into quite a task. And it's also very unforgiving, you know. Being in games, we all know that stuff changes, right? It changes all the time, up to the last second, the last build. But if a story shifts or the character changes or a level changes, it's very hard to get back in and capture that data again. Which brings us to desktop facial. And as you see in this demo, desktop facial, sorry. It's a tongue twister. Desktop facial is a quick and simple way to get believable characters, believable facial animation right on your characters using a webcam. The team at Mixamo tried different solutions in the past and weren't happy with the results, so they put together Face Plus in a year and a half. And we used Face Plus on Unplugged because honestly, it was the best solution for what I was looking for as a user, right? It was the best solution because the quality was really high. And that's not always the case with desktop facial. And this is the first system that I've used in my 16 years that I was actually really happy with. The turnaround was also instant. You know, we were allowed to experiment and take chances or push the scene. And we had Ross, our actor, that's our actor there, Ross Travis. We used him to capture our face, or we used his face for the game. But there's moments when the animators wanted to go back in and try something different, you know. Face Plus allowed us to experiment with that and have that flexibility. Fourth is we are able to have a consistency across the board. You know, we knew we were going to have a level of facial animation that was at least pretty high, and then we can go on top of that and enhance it if we wanted to. And also we were able to capture the mood and the emotion that each scene needed. And this was really important because sometimes some scenes need a lot more emotional push than other scenes. This system allowed us to do that. But most importantly, Face Plus allowed us to show our story through facial animation and not tell it through dialogue. Right? We were able to show what was happening between the character's ears and behind their eyes. We were able to show what the character was thinking and what the character was feeling. And we were able to do so in a short development cycle with a small team. And that was pretty awesome. So those are the 4 options for creating facial animations in game. And I also want to say that though Face Plus was the obvious choice for Unplugged, there isn't really a wrong solution, right? It all comes down to your budget, your time, your talent pool, and what your project calls for. You may be happy with one solution, or you may have to mix them all. But it's what your project needs. And if you look at these awesome characters up here, right, they all need different solutions. So find the solution that gives you the results you need in a timely manner, and then spend the rest of your energy focused on creating compelling characters and freakishly amazing gameplay, because really, that's really what it's all about, is great gameplay. All right, cool. So I'm going to hand you back off to Stefano and Charles.
Yep. Thanks a lot, James. So we're going to do a live demo of this. You've seen a little snippet during the keynote. And now we're going to show you a little bit more of that, and then also what the process is to take a character, apply animations, and then bring it into Unity and Mecanim. So we can switch now to the other computer. So we are using basically a standard webcam. Like this one, it was like $30, I think, on Best Buy, something like this. So nothing special, no special hardware. And now I'm basically animating the character in real time. So I can move the eyes because they are all tracked. I can make a big smile, hey, what's up? And I can do all kind of funny expressions, be super sad, super happy, hey. And so the beauty of this is that it really doesn't require any calibration, so we can swap performers. So we can have now Emiliano try it. And we try to basically make something that works like straight off the bat. People don't have to do any calibration. They don't have to do basically anything. They can just pop in front of the camera and then make the expression they want. One thing that we realized right away was that humans are pretty consistent in the kind of expressions that they can do. But characters, you may want to exaggerate a lot. So we had to basically, we tested a bunch of systems a while ago, and then we realized that none of them was allowing the artists or the game developers to actually push the character side. So we basically went back to the drawing board and implemented some machine learning-based technique. Maybe Emiliano can say a little bit more about this.
Yeah, sure. So basically what we did...
I can take the camera.
So what we did back in last May, we checked out the state of the art. There has been a lot of work on facial animation, face detection, expression recognition. So we looked into this algorithm. We selected the best performer. We make them perform better. Also with the help of AMD, we made them run faster on GPU. And then what we did is that we packaged them into a framework that make these different components work in a synergic way. So basically, you have an algorithm that maybe has strengths and weaknesses, and another algorithm that have different weaknesses, and the two compensate. So the work of this ensemble of algorithms is way better than the single algorithm. So, yeah.
So we packaged this into a product that was released yesterday. It was our first day. We got a lot of press and interest, as you can imagine. And there are a few things now that we're going to go through, and how we built it and why it's a good choice for game developers. Because at the end of the day, we were trying to inspire you for your cutscenes or even for your in-game animation. So, do you mind?
Sure.
Wait.
Is this on?
Yeah, I have a few on.
Hello? Okay.
And so the idea basically was, okay, these were the three things that we wanted to achieve. We want to use standard hardware. It needed to be a real-time, single-click process. It was leveraging blend shapes. So Unity 4.3 was in progress, so we realized, okay, we can take advantage of that and then have a much simpler pipeline using blend shapes. And then the main goal was to bring as much life as possible to the actual character. So we have basically the performer, we have a character, what was the shortest path? So we discovered that the super short path was actually not working in the sense that the performance of a human doesn't transfer perfectly on the performance of a character all the time. Because characters have massive exaggerations, and they may have different mouth. There is a different anatomical shape, morphological shape than a human. So we need to build an intermediate layer that we call character-specific meta layer, where this mapping from the input human performer to the character needs to basically do the magic. So that's where you going there, tweaking, will completely change the outcome, because all of a sudden your character can do the huge smile, like cartoon style, and then can exaggerate all those expressions the way you want. And they're a lot more exaggerated than in a human. And we were able to do this in the Unity editor in real time, and people can basically perform and then tweak those parameters. So there are two parameters, gain and offset, that Charles will talk about in the next couple of minutes, that allow you to basically create those exaggerations as you are performing in the editor. And this is basically giving what? It's giving freedom. I mean, who doesn't like freedom, right? So it's good. So I'm going to leave it now to Charles. The last slide I wanted to show was just, these are all the blend shapes that are needed to drive it. We built this Mixamo face rig in collaboration with a lot of people from the film and game industry. This is what we have shared with the Mecanim team. And these are all the ones that are directly driven. You can add more, or you can have a lot less. You can have a single blend shape, and then the system was still able to drive it. But this is basically just to give you an idea for this specific character what the setup was. Charles?
Cool. Okay, I'm going to walk you through sort of setting up a character for the first time. As Stefano mentioned, there are about 50 blend shapes, everything from right eyebrow up, inner right eyebrow down, left inner eyebrow up, left inner eyebrow down, mouth smirk, nose scrunch, eye squint, and then again, left and right sides of the face. So you could have an asymmetrical character or have a character with some interesting properties. So first things first, I have a prefab of my boy that just has some materials on him. I'm going to drag him into my scene. We take a look at this. It's pretty standard. We've got some meshes. We have our rig for the character. We're only really interested in the face, specifically the boy's head, where all the blend shapes exist. Okay, first things first, I grabbed the most sensible, the sort of base game object, and I'm going to add a face plus connector, which is what kind of brings everything together. I connect my face mesh to the face mesh slot, the head joint, and the left and right eye joints, which are just standard joints. They're not driven by blend shapes. Left eye. Right eye. And again, these are just in my hierarchy of joints in my rig. Okay, and that's it. I push play. So the way that this was so, if I can get a model.
Thank you for the compliment. I appreciate it.
You're very welcome. So the way this was so easy is that we followed our standard, our face rigging standard of blend shapes. It's just a naming convention, basically, and the set of shapes that we require. There's not much to it more than that. Our interface allows us to record and play back, and it will generate an animation file at the end of it with the curves that you're familiar with seeing from our demo yesterday. On the first day of the conference. Right, as Stefano mentioned, you can customize your character with gain and offset for each of the blend shape channels. And I'm going to show you quickly how to do that with our Face Plus Shaper, which is basically just two values. One is the amount to multiply the value that we're getting out of Face Plus, and the second is the offset. So if I want my character always to have like a compensation for how much his mouth should move, if I always want it to be maybe double or 20 times the values that we get from Face Plus, I can do that. Or I can make him, sort of more like Elvis, always talking with a left lip curl. Super easy to do, so it's in your animations. You don't have to do the correction in post. The offset as well will do sort of just a base push. So if my mouth is always supposed to be a little bit open, I can compensate for that. I don't know what that would be appropriate for. Maybe my right eye is always squinting, something like that. You don't have to make the actor do it. Okay. So I'm going to show you quickly how I can create an animation and then drop it onto my animator controller. First, I'm going to create a new take. It'll let me save it somewhere. And I will hit record. Stefano, you want to do something for us? All right, here we go. It's an interesting performance. So I push stop, and it bakes out my animation to just an animation file. It will be saved in my project folder at the base of my project, or wherever I chose to save it. And to connect things, all I have to do is add an animator controller, or excuse me, an animator. Create an animator controller. Drag that on my boy. Go into the animation window, which I believe, or the animator window, excuse me. Add a layer. So the thing that's interesting about sort of the setup that we've decided to go with is that you could have a base animation on your body and have a separate animation on your face. For example, if you were to download Mixamo animations and apply them to your character, you could easily have a face setup that's not necessarily attached to those animations. And it might also make sense for your rig or how your pipeline works. So I'm going to quickly create a new layer for my face. It's important to set the weight to 1, saying that this will use the full value of the animation curves on this, and set it to override so that it will override any curves that might happen to be on the base layer. I have an avatar mask that I call the empty mask, and this just makes sure that nothing that's on the body is affected. I mean, we're not generating any animation curves for those things, but it doesn't hurt in case you maybe animated outside of it. Fairly common practice just to make sure your humanoid is not affected. Okay, so on my face layer, I can drag in my take. And on my base layer, I can drag in an idle animation, which I believe I have. What is this? Idle 2, idle 1. No. Where's my animation? That is the question. Oh, here it is. There we go. I'll turn off Face Plus for the purposes of this. And we'll check out our scene, our game. So this is Stefano's animation being played back, and we have an animation on the body of the character. It's that simple. Okay, again, if you're not happy with your performance for some reason, maybe you want to alter some aspect of the performance, it's fairly easy to open up your animation window with your character selected and modify some of those curves if the animation window responds. This is Unity 4.3 Alpha 5. Here we go. So I choose my take. I can see that I've got some animation values on my dope sheet here. I'm going to open up my battery boy head, click curves so I can see the more interesting stuff. And if I unfurl, which is my favorite new word, the battery boy head, I can see, for example, my list of blend shapes. I can check out, sort of scrub through and modify them. You'll notice that the teeth aren't responding here. That's because we've done some custom stuff that is off the rig, and I'll show you how to do that in just a moment. And yes, I can edit by dragging in and fixing or deleting curves if I'm not happy with them. Cool. Okay. So yeah, let's talk about the teeth. What did we do in the teeth? Why did we do it? So we wanted to show how easy it would be to listen to sort of what we're doing to the blend shapes and to modify them. And one thing that we did for the teeth is just create a custom script that modifies things so that we can show how that's done. The few things that we're doing in this script are finding the mouth open blend shapes, the smile left blend shapes, and the smile right blend shapes using some of the new API calls. There's a get blend shape name that is on any mesh renderer. You can also get the number of blend shapes that are on a given mesh renderer. So we find the index because that's how the API requires us to access them. We save those indices out. And then in our late update, which happens after animation is applied, we get the values, and then we can perform some math to do some corrective blend shapes or to do additional blend shapes, as in the example, our example, which is to modify the teeth mesh blend shape. We have sort of a stretching of the teeth as the mouth gets bigger to do a cartoon style grin, excuse me. Cool. So let me plug that in. We can see that correction. Actually, I have it ready on another scene. Well, I'll plug it in. I happen to know this magic value is 30, and that is 2. The head joint smoothing is something that we just added to show that you can modify how we're sending animation out. Connect my teeth. And my pointer, this is just the battery indicator on the boy so that he has an interesting level of power. So now you notice that the teeth are responding to the blend shapes of mouth open and stuff. It's not, they're not close together, and if you can see on the smile, they do get wider. Okay, so with this system, most of the code that we're shipping is going to be open, available for you to edit, to contribute, to do what have you. It is fairly easy to customize. For example, we have this blend shape driven rig, but the values that we get from Face Plus are just float values, and you can do whatever you want with them. You could use the Face Plus values to drive your video game play style. We have another implementation that is a set-driven key or bone-driven implementation of face rigs. And if any of you are riggers or have rigged a bone implementation, it's rather difficult, but it is available in 4.2 even because it doesn't require blend shapes. So you can get started today animating with the face. Yeah. Thank you.
Thank you, Charles. I want to go back to this aspect of having this meta layer, character specific, that we left open. So it will be very easy for you guys, even after recording the performance, to go there and tweak those values and exaggerate those poses, even after the performance of your actor has been recorded. So there's no need to re-record that. Another thing that I want to mention is tied to what the budget is going to be for this. So let me bring you back the blend shape list. So in general, if from a production perspective, if I have to get the same level of quality on a bone-rigged character for facial versus creating blend shapes, usually blend shapes is a lot cheaper. First of all, your modeler can do most of the work, and then you just need to hook it up. But you don't have to figure out how to push those limits, how to push those poses using the bone skinning, which is a little bit more intensive, and it may take your rigger maybe a couple of days. Instead, modeling the blend shapes is usually a much faster project, and it usually takes probably a few $100s overall budget. So it's a lot more affordable, and it's also a little bit cleaner the way you bring into your project, because it's a closer to a one-to-one mapping between what the performer is doing and the blend shape that gets activated. So we get, I don't know, a float that says happy or sad, and then you will have a blend shape or a group of them that are being activated when that happens. So it's a lot easier to understand what's going on as opposed to having, rotation values on bones or things like this. So we, as Josh said, we released for both 4.2 with bones and 4.3 with blend shapes, but the workflow with blend shapes, of course, is more straightforward. It's more like a direct path. One last thing I wanted to say about this is that all this is available on our site. So not only Unplugged is available, but also Face Plus, the project that you just saw. It's about a gigabyte of goodies. All these texture maps, very high-res character. It's not only available on Unplugged, but it's also available on the Face Plus, with the Face Plus project. So we always ship a Unity project that is ready to go. There's a demo scene, and then all you have to do is just swap the assets in, and then you can put it in your game. So I would love to hear from you guys, how many are planning to create cartoon-like games or games with cartoon characters versus realistic? Because we are now in a phase where we want to hear as much as possible from the community and understand what the needs are. This just came out yesterday, and then now is the time for us to listen. So maybe we can do a quick poll. So how many of you are interested in the cartoon type of characters? And then how many of you in the realistic one? All right, so almost like 50-50. So we got to do both, I guess, right? Okay, so we will leave a little bit of time for Q&A. You're welcome to walk to the microphone. The last thing I want to say is a really big thank you to AMD and Unity. They have helped a lot in this project, both with engineering support and figuring out all levels of the tech. The Mecanim team has been fantastic to collaborate with. And I heard that for the first 10 people tweeting about this, we're going to give out Mixamo t-shirts at the booth, which is the first one right on the left when you get out. So you better rush out after it's done. If you go now, it's invalid, so you have to wait until the end.
What is the accuracy of mixing audio with the face animations, like you would see with the procedural facial animations?
Take this, Stefano.
Yeah, so the one thing that we can do is just record the audio at the same time, so you have it as a reference. But at the moment, we don't have a solution that will do the lip syncing with the audio and then everything else with the mocap. We believe that if the mocap is of amazing quality, you don't need to leverage audio for the phonemes. That's kind of the direction we are going to. Otherwise, blending the two together will be adding another layer of complexity that may not necessarily provide the best performance.
I can add to that. So one thing you could do is in the new 4.3, there's this animator go-to state, and you can send a normalized time. With that, you could look up how far you are in your audio clip and synchronize your animation to that. So if you know your offset from, I don't know, the beginning of your clip is a certain amount of time, or you've already timed it so that your audio clip is the same length as your animation or something like that, you could sample the audio time and use that to drive where in the animation clip you're playing.
Yeah, my question is actually exactly the same as his, but I'll just put it in as a feature request because we already have a pipeline that takes audio, extracts the volume information, just the mouth shapes. So we'd love to be able to combine that with the facial animation from your system. So if you're going to allow that to be possible at some point, that'd be great.
So then I have a question for you. So how would you envision to mix the two together? So let's say you already have a bunch of audio that has been processed, so mostly lip syncing, and you don't have anything in the rest of the face.
Right.
So you're thinking, okay, I can play back that animation and then layer what comes out of Face Plus on top of it?
Yes, exactly.
Okay, this is already possible.
Okay.
Yeah, so this basically, you can use layers and you can mask. So you will have to basically play the blend shape animation in Mecanim, and then you basically mask just the mouth and you play whatever you already have. And then you're going to use Face Plus with another mask that will animate everything else.
Or just name your blend shapes differently so that they're not driven by Face Plus. And then you just animate what you're interested in animating, be it the eyes or just the mouth.
Now, I'm not clear though, is the mask not either or? You can't combine things. So
the mask is actually just for the humanoid skeleton. It's only the sort of Mecanim retargetable mesh. So we spit out a certain set of blend shapes that we know about, and if they don't exist, we don't animate them. So if you don't want us to drive your face, you just don't give us those blend shapes.
Right. For example, let's say I'm talking, and so I already have the mouth shapes, but I also want to smile at the same time.
Oh, I see.
That's more complex.
It could be more complex, but not necessarily. So if you've already got animation on the blend shapes for talking, blend shapes do that magic for you. That's what they're great at, is mixing between multiple poses. So if you have just a smile that we're driving, and you have the mouth up and down motion that you're driving with your existing animation, it's not a problem.
So it should just work.
It should just work.
It's basically linear blending between blend shapes, and so you will have just layer, and then you use the standard like additive layers and so on that you have in Mecanim. Yeah.
Okay, great, thank you.
Hello. I was wondering, are all the characters already set up for this in the All Access Pass?
So right now we have, I believe, 4 characters. There are 2 of them are the ones of the short. Those are basically available freely. They can be just downloaded from the Unplugged webpage. And then we have another 4 that we are putting out. And then, with time, we are trying to get more and more characters to have blend shapes. So if you have specific characters that you like, that you want us to create or to port to having facial support, please let us know, and we can prioritize based on that.
Okay, thanks.
I know this might be sort of an unfair question, but
We'll
with regard to
Emiliano then.
if you're capturing video, what if you had some video that was not made specifically for that? Like, how robust is it when the face might be turned or stuff like that? Hypothetically, could I take a movie and define a target area, or I could edit it in Premiere or something and isolate a performance from a movie and then use that?
Okay, you should come to our booth. Is it on? Okay. I mean, if you come to our booth, we can show you like this device tracking a movie playing on the iPhone. So you can take a first close shot of a person talking, and then play it in front of a webcam on your iPhone, and it tracks.
As far as like angle of head, there are some limitations. You have
15.
to have sort of 15 degrees.
For now, it's 15 degrees. So
Yeah, okay, but the core thing is you can actually just feed it video. It doesn't mind whether it's live or recorded.
Yeah, so also in addition to sort of the workflow I showed you, I neglected to show you this other half, which is you can use, oh thank you, Stefano. You can use existing animation, excuse me, I don't have my animator attached. You can use existing videos to drive the animation. So you just plop in a video, WMV or movie file, you set the frame rate, which it should detect automatically, and hit record. And it will have the video on screen and show you side by side what it's capturing and what's playing in the video.
This also works really well with capturing audio. There's another audio question, but you can actually, when you're doing the audio for your game or your cutscene or anything, you could film yourself reading that audio and then pump that video back in here.
So
Thank you very much.
Yeah, this way you have the two already synchronized.
Yep.
My question is somewhat similar. I was wondering about what the limitations are for the webcam, the frames per second. I noticed sometimes I had a hard time picking up blinks because they were real quickly, and what those limitations were.
So it's interesting that on this machine, for example, the frame rate of Face Plus is way higher than the 30 frames per second of the webcam. So the webcam is capturing at 30 frames per second. Our eyes are working at about that frequency. 24 is film, 30 is the frequency that our brain can detect. So from the Nyquist theorem, 60 frames per second will give you basically the full performance, ideally. So if you have a camera that is faster than 30 frames per second and you want to use that one, we are basically a hardware agnostic, so it will work in that way. I don't know, Emiliano, if you want to add something to this.
Sure. I mean, if you're moving like very fast, you're making fast movements, then a camera working at 60 frames per second can really help. But normally for lip syncing, I think 30 frames per second is plenty.
I'm just curious about Fuse. I went to your other seminar and got to see about Fuse. Is that supported with the system as well? Will it have the blend shapes?
You must have like a crystal ball.
Sorry, what's that?
No, I said you must have a crystal ball at home because, yeah, it's something that we are getting a lot from the community. And so we're thinking, okay, what if all the Fuse characters, all the heads were rigged with blend shapes ready for Face Plus? So it makes complete sense, and it's definitely on our roadmap. So if you feel the same and you would like to have to use Fuse with our facial animation technology, speak up, let us know so we can fast track it. We got a lot of feedback, fantastic feedback from the community in these last couple of days. So the more we hear from you what you need, and the faster we can prioritize it. Thank you.
I'd just like to say that what you guys have done so far is pretty amazing and incredible.
Thank you.
And I'm just curious if you have any plans in the future to combine the lip sync along with the facial animation so that it all can happen at the same time. And if so, if those blend shapes that you're talking about on the current characters, if those would include all the phoneme mouth shapes for lip sync.
So let me a little bit go back to what we just discussed. So if your mocap is perfect, right, you don't need the audio to drive the lip syncing, right? So if ideally you can measure all the blend shapes and all the shapes of your mouth, you will not need audio to drive it through the phonemes, right? The only exceptions to this will be the animation of the tongue. That it's really hard to get, maybe not impossible, but we haven't tackled that
We've thought about
yet.
it. It's the #1 requested feature.
Yeah, seriously. So basically, we try to stay away from using the phonemes, but we still have the phonemes in the blend shapes, so we can basically push them through motion capture as opposed to through audio. Combining the two solutions is a little bit of a bigger scope, and then you'll be in the situation where you don't know which one to believe, and you don't necessarily have a way possibly to assess which one is actually closer to the truth, because they're kind of operating on orthogonal ways. So
I'm sorry to interrupt, but you're saying the existing motion capture solution that you have actually can capture the phoneme shapes and target them to the appropriate phoneme blend shapes. It's just that you just chose not to do it in this example?
No, I said that we have some already. We have the main ones. We don't have like the weird, maybe the P, when you basically roll your lips inward and things like this. We may not have all of them, but we have been adding, as the technology improves, we are able to track more and more phonemes. So at the beginning, we were just tracking, one line, basically one edge of the mouth, and now we actually have, we can resolve on the thickness of the lip. So if you can roll in and roll out, we can start detecting that. So as the technology improves, we will be able to recognize all these phonemes. Now we already have some, but the goal is to basically be able to recognize and detect all of them.
Okay, so I can understand that it's not going to be generated from the audio per se, but if you want to use the audio, then it would make sense, right?
Okay.
But that's something you said you were working on?
I think we will try to push as much as possible the purely mocap and trying to detect the phonemes using mocap before we try to leverage the audio side of things.
And as mentioned,
but just to be clear, I wasn't suggesting that you use the audio to drive the blend shapes. I'm just suggesting that the audio be recorded at the same time.
Oh, absolutely. So this is like the #1 feature that we got asked. So it will be in really, really soon. Yeah.
Great, thanks.
Hi. So you guys have this great auto rig feature for models that we've created and that we want to bring into the Mixamo environment. How would you support using a custom model that perhaps like in Maya, for example, you've done blend shapes with but haven't rigged? Is that something that you guys are working on as well?
You're talking about body rig or facial rig?
Either. Like if you had a character model that you've brought into the Mixamo environment to use the auto rigger, how would you then take that character and put it into the Face Plus system?
Okay, yeah, so very good question, thank you. So the auto rigger only rigs the body, as you know, but you may have created the blend shapes separately, right? So what you do is you upload it with a standard blend shape. The whole head will be rigged to a single bone. And then you can basically use the blend shapes in Mecanim to drive all the facial. So they're not mutually exclusive, they actually work together. And then you can also mask in Mecanim. If you want to have a joint on the neck, basically you can decide, is the neck going to be driven by the facial animation or by the body animation? Or maybe a blend of both, right? So you can also do that as well.
Okay, great, thank you.
Thank you.
How well does the motion capture handle things like facial hair, glasses, a range of skin tones?
Emiliano, do you want to take this?
Facial hair, glasses,
facial hair
skin
and glasses.
tones, quality.
Yeah, I mean, we tried with any kind of like facial shape, race, and age. And it's pretty robust, and this because this data-driven, we use a data-driven approach, machine learning, and we use we train this algorithm with a lot of subjects coming from a different race and shaved and not shaved. We currently have some issue with the glasses, so you need to take your glasses off, otherwise it capture glasses, consider glasses basically eyebrows. But aside from that, it's pretty robust across facial shapes.
Yeah, the glasses is not tied to the limitation of the technology, is that because it's a data-driven approach, we will have to capture subjects with all different brands of glasses, right? So that we can learn, oh, that is a glass object and can have 50 different shapes. So it basically adds like one extra layer of complexity. So we decided to instead not do that, because this way we can get a more accurate tracking on the eyes, knowing that there's no glass, as opposed to trying to support a bunch of different glasses and then get maybe a 70% okay solution.
I will note, though, that we learned this week that Google Glass is supported.
Thank you, Charles. Okay, I think we're good. Thank you very much, everybody, again, and stay in touch. You can check out the demo at the booth outside. Sorry for interrupting the clapping.